Welcome to this MCAT Mondays General Chemistry Episode 1. It's going to be the actual MCAT content. So, yeah, let's get right into this. Okay. So I'm just going to give the basic stuffs right now, and then we're just going to progress our way to the actual meat of the stuff later on. So, in a periodic table and basic elemental nomenclature, you got an element symbol, let's just say it's X here, and you got a proton number like right here, usually, and the atomic number, or the atomic mass, AMU, will be found on the top left, and that's the general nomenclature, usually. Nuclear decay is, has a different proton symbol where they put Y. Let's just say, let's do X as well, and Z would be the AMU, and these would be your proton number. Yeah, okay. So the mass number, which I just described, which were these two top values, Y and Z. I'll just stick with Y right now because that's the general stuff we're going to be doing until we reach nuclear decay. So Y would be your AMU, and that's going to be equal to P protons plus neutrons. Okay? And I'm just going to give you the weight of the one of these protons and neutrons, which is like 1.667 times 10 to the negative 27th kilogram. So pretty small stuff, but they weigh way more than an electron, and significantly more. So that I'll explain why that's significant. So some general stuff on the subparticles: protons, neutrons, and electrons. Protons have a charge of +1. Neutrons have a charge of 0. Electrons have a charge of -1. Let's do charge right here. AMU, or atomic mass, unit of a single one of these, would be 1 for protons, 1 for neutrons, 0 for electrons, and that's the importance of the subparticles for general chemistry. Now, all these protons, neutrons, and electrons have significance in the sense that they can make ions with depending on how much of each quantity of protons and electrons you have. So an ion can either be a cation or an anion. Cation is positive charge, anion is negative charge, which means that it loses an electron, and this one gains an electron. Okay? So positive charge for cations, negative charges for anions. And just for like general tip, lighter nucleuses are generally more stable. You got, let's see, yeah. And you can make isotopes by changing the number of neutrons in the elements. So let's just say copper has this. Copper would have the same number of protons, which would be 23, I believe. have to check that out. You can look it up in the periodic table. But let's just say it's copper 63 versus copper 65. Main difference is in the number of neutrons. This will have 2 more neutrons than this one. So that's the difference in that in the isotopes. Now, these isotopes, when added together, they give the average mass on the periodic table. So like in the periodic table for copper, again, let's use that as an example. Copper has an average mass on the periodic table of 63.546. Copper 63 obviously has an atomic mass around 63, 62.93 to be exact. And copper 65 obviously has atomic mass around copper 65, around 65, which is 64.928. Okay, and basically what to do to find this average mass, you got extra quantities here based on the percent abundance. Okay, percent abundance for these would be different. Let's just say, and because 63.546 gives you a clue on how much percent abundance it is by showing you how much like the quantity is closer to the isotope most prevalent. So 63 is the most prevalent, as you can see. Otherwise, it would be more around the range of like 64.9 if it was copper 65. So let's just say this is the percent abundance. X for percent of X, copper 63, Y for percent of copper 65. Let's say that equals to 1. Okay? And in order to find the average mass, all you gotta do intuitively is 62.93 times X plus 64.928 times Y, and that equals 63.546. Okay? You getting all this, cameraman Sam? Huh? Yeah? Okay. It's all clear, right? Good? Let's go for Bohr model. Now this model is obviously wrong because nowadays we all know it's like an electron cloud as the actual model, not actual rings of electrons. Okay? So a nucleus has protons and neutrons. And you got rings for this Bohr model of shells. Okay? 2 for the first one. 8 for the accompanying levels of shells. Now there are S, P, or orbitals, my bad, orbitals. S, P, D, and F orbitals for this model, as well as for the accompanying explanations later on. These terms are very important and have a lot to do with the emission and absorption spectrum as well. And speaking of emission and absorption, that has to do with energy. And photons of energy I don't know if I mentioned this, but those like little electrons, those are electrons, those little circles over there. Protons, neutrons, nucleus, these shells have electrons. Yeah. So, let's see. In order to, photons of energy can be released or absorbed by the electrons in an atom. Okay? So let's just say, again, nucleus, orbitals. Let's say you got an electron right there. If it absorbed energy, it would go to this energy level. And if if it emitted energy, we go to this energy level. Alright? Absorb, higher energy. Absorb, higher energy. Emit, lower energy. Makes sense because you're releasing for emitting, absorbing, yeah. I'm going to go over this last concept because I know you guys are probably not going to be paying attention to a 20-minute long video. So I'm just going to break this up into chunks. So for the absorbance and emittance, that has to do with energy. And energy is Planck's constant times frequency of the energy spectrum or energy level or wavelength. Wavelength. It's like forms of energy, wavelengths of light, and this frequency can be also put in terms of speed of light times wavelength of that specific energy spectrum. If I need to clarify more, just let me know. H is Planck's constant again. That's 6.626. Oh, just write it more clearly. H is 6.626 times 10 to the negative 34 joules times seconds. And in electron volts, it's 4.136 times 10 to the negative 16 electron volts. You guys should memorize this. It's very important for the MCAT. They'll probably give you the values for the electron volts, but you should definitely memorize the basic joules times seconds. Okay? And obviously, C is equal to the speed of light, which is 3 times 10 to the 8th meters per second. Okay? That's all the time we have left. Hopefully you guys understood all this. I'll be back next time talking more about energy absorption and more about Aufbau principles and emitting and absorption of electrons. Hope you guys learned a lot. Thank you again. This was MCAT Mondays. Let me know how you guys think. And yeah, send me some questions too. All right.